Homework sheet U11d question 2, part A. In this question we are given a substitution x equals u squared, and we need to rearrange the integral in terms of x into a new integral in terms of y. First thing you should do is differentiate your substitution. So dx du is equal to 2u. We can then rearrange this to get dx is equal to 2u times du, and we can make that substitution into our expression. We still keep a 1 on the top. Our x we can replace directly with u squared, and our root x is therefore going to be equal to u to get a 2u minus 1 on the bottom, and we'll replace the dx with 2u du. The u on the top can cancel out a u on the bottom, and this then gives us the integral of 2 over u 2u minus 1 with respect to u that we've been asked for. Part B now asks us to perform that integral with limits 9 and 1, and we are given a show that question, so we need to give our final answer in the form 2 log a over b. Now I've made the substitution for the answer that we already had in part A, but I also need to change the limits as well. At x equals 9, u squared is equal to 9, so u is equal to 3 or minus 3, but we're told that u is bigger than 0, so u is equal to 3. And at x equals 1, u is equal to root 1 plus or minus 1, but again, as u is positive, u is equal to 1. So I've now got new limits I can use. To integrate this expression, we need to use partial fractions, so I'm going to have to do a little bit of an aside and figure out how I can rewrite 2 over u to u minus 1. It's going to be something of the form a over u plus b over 2u minus 1. If I multiply everything up, I can get 2 is equal to a lots of 2u minus 1 plus b lots of u. And I make some substitutions. At u equals 0, 2 is equal to minus a, so I now know what a is. And at u is equal to a half, at 2 is equal to half b, so b is equal to 4. So I can return to my original integral, and I can replace it as the integral of between 3 and 1 of minus 2 over u with respect to u plus the integral of 4 over 2u minus 1 with respect to u. Now both of these integrals are going to be logarithmic. We've got a standard pattern of some constant times the differential of the denominator. So I'm going to start by just doing a little bit of rearrangement. I can take out that minus 2 as a common factor to get minus 2 lots of the integral between 3 and 1 of 1 over u, because 1 is the differential of u. And I can take out a factor of 2 from the top one to get the integral between 3 and 1 of 2 over 2u minus 1. And again, 2 is the differential of 2u minus 1. So, when I do my integral, I now have minus 2 lots of log u to substitute in 3 and 1. And I have 2 lots of log 2u minus 1, again between 3 and 1. So I can take that 2 out as a common factor, and this gives me minus log 3 plus log 1 plus 2, sorry, the 2's already taken out of the factor, log 5 minus log 3. No, sorry, that's log 1. Okay, the minus log 1 and the plus log 1 cancel, which gives me 2 lots of log 5 minus log 3. I can write this as log 5/3 using log laws, and then I can bring the 2 up as a power. No, sorry, that's how I need to leave it.